I will show you how to do the forces worksheet. I'll talk kind of fast, so feel free to pause if you need to hear things over again. Part 1, if you look right here, identify each of the following as a mass or a weight. I'll show you a couple examples, then we'll pause it, and you can try. But this first one here, this is a mass because it's in kilograms, so I write mass equals. This is a force weight. Notice the units. It's in newtons. This next problem, number 2, says draw the forces for a cart at rest on a horizontal surface. I always start with my dot to represent my force. There's always a weight force. Since the cart is on a horizontal surface, there is a normal force as well. Label these force normal, force weight. Congruency slashes because they're equal. And there's no mention of left or right action, so I'm done. Try to do number 3 and then pause the video. Pause the video right now and try to do number 3. Okay, here's the solution to number 3. I know there's a weight because there's always a weight for anything on Earth. I know there is a normal force because it's on a horizontal surface. I know there's a person pushing it to the left. There's no friction. This is an applied force because it's from a person pushing it. This would be acceleration, not constant velocity, because there's an unbalanced force on it. Number 4, try number 4 and then pause it. Here's my answer to number 4. Draw the forces for a cart on a horizontal surface. A person is pushing it, but there is friction. Everything's the same, but now I'm going to add friction. There's weight because there's weight on anything on the surface of the Earth. There's a normal force because there's a surface. There's somebody pushing it to the left. That's an applied force. This time there's friction, but because that accelerates, I know that the applied force is greater than the friction. Try number 5. Now here's my solution to number 5. Now the cart's moving with constant velocity, so all of my forces are balanced. These two are equal. These are equal, and now we label normal force because it's on a surface, the weight because it's near the Earth, friction because it's opposing the motion, it's going opposite to the motion, and the applied force. Try number 6. Pause this as often as you need to. I'm going kind of fast. This one's being pulled by a rope to the right, and there's no friction. So, again, I have my normal force because there is a surface. I have weight because the Earth pulls everything near the Earth, and it's being pulled to the right. This is called tension. I don't know if I've talked about that much, but because there's a rope, there's tension. This is going to be acceleration. This previous one was constant velocity. Number 7. Hey, I'm going fast, but you can pause this as often as you want to. A box is on a horizontal surface. There's friction, but the box accelerates. It's pulled by a rope. Friction opposes the motion. This box accelerates. Notice there's an unbalanced force here. The tension's greater than the friction. If a person is standing in an elevator that's accelerating upward, if you imagine the box of the elevator, here's the person. They're standing there. There's a normal force on the person, but here's the thing. The normal force actually got greater than the weight. The weight never changed, but that normal force is greater because it accelerates. Don't mind the noise, it's just people walking in and out. A person standing in an elevator that's accelerating downward, the weight is no different. That's just caused by the Earth. But when you feel that funny feeling on an elevator, that's because your normal force is different from your weight. In this case, it's less than your weight. So notice acceleration, 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 unbalanced, 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 unbalanced. The only time you have constant velocity is when the forces are balanced.